Millions of investors are investing trillions of dollars in AI. A technology losing money. A technology losing a lot of money. Why are they doing this? They believe today's AI, based on large language models, will grow into artificial general intelligence, the god of AI. All they need is bigger data centers, millions of GPUs, and an infinite amount of energy. All you have to do is write a check. LLMs, they tell us, will magically evolve into AGI. It looks good on a pitch deck. It looks great on the stock exchange. But is it real? Will LLMs ever become AGI?
In the last few years, large language models have transformed the way we think about artificial intelligence. They write, they reason, they summarize, they code, and they do it with a fluency that often feels uncannily human. It's no surprise that many people now wonder whether these systems are early steps towards artificial general intelligence. But beneath the impressive surface, there's a growing debate amongst researchers, engineers, and cognitive scientists, myself included, that LLMs, for all their power, are built on foundations that simply can never scale into true general intelligence. Not because they're weak, but because they're fundamentally the wrong kind of system. In this video, I'll explore 10 of the most important reasons behind that argument. 10 structural limitations I believe prevent LLMs from ever becoming AGI. Not hype, not fear, but the real technical challenges that shape the future of AI. When we talk about intelligence, we often imagine something that understands the world the way we do, through experience, through senses, through trial and error. But large language models don't have any of these. They don't see, hear, touch, or interact with reality. They don't build mental models of objects, physics, or cause and effect. Instead, they operate entirely on patterns in text. They predict the next word based on the words that came before. And that's all they do. So when an LLM gives an answer that sounds insightful, it isn't drawing on lived experience or grounded knowledge. It's drawing on statistical echoes of human writing. That's why these systems can sound brilliant one moment and stupidly wrong the next. Without a connection to the real world, they can only simulate understanding, and simulation is not the same as comprehension. This gap is fundamental, and it's why I argue LLMs cannot be the foundation for true general intelligence. One of the biggest misconceptions about LLMs is the idea that they want things or that they somehow working towards a goal. They aren't. LLMs have no desires, no intention, and no internal drive to act. They don't wake up in the morning with a plan. They don't decide what to think about next. They simply wait for a prompt and then generate the most statistically likely continuation of the prompt's text. This means they can't form long-term strategies. They can't pursue objectives, and they can't even evaluate whether their own answers are useful or correct. There's no inner loop of reflection or motivation, just prediction. And that's a fundamental limitation. General intelligence requires an agent that can set goals, make decisions, and adapt its behavior over time. LLMs don't do any of that. They're reactive, not proactive. And without agency, they remain powerful tools, but not candidates for AGI. One of the most surprising things about LLMs is how confidently they can produce information that's just utter rubbish. We call these moments hallucinations, but that word almost makes them sound accidental or mysterious. In reality, hallucinations are built into the very architecture of these systems. An LLM doesn't know what's true. It only knows what's likely to appear next in a string of words. When the model doesn't have a clear answer, it doesn't stop. It doesn't ask for clarification, and it doesn't check its work. It simply generates the most statistically plausible sentence it can. Hallucinations aren't bugs we can patch. They're a structural consequence of prediction-based intelligence. And if a system can't reliably separate fact from fiction, it can't be trusted to reason, to plan, or to operate autonomously. For me, this alone disqualifies LLMs as a foundation for AGI. For years, the story of AI progress has been simple. Make the models bigger, feed them more data, give them more compute, and they get smarter. And for a while that worked astonishingly well. But now we're running into the hard edges of that strategy. The largest models on the planet already require massive data centers, millions of GPUs, and staggering amounts of electricity. We're approaching the limits of available high-quality training data. And each new generation delivers smaller and smaller improvements, despite exponentially higher and higher costs. This is obviously diminishing returns. Scaling alone is no longer giving us the breakthrough it once did. And if your entire path to AGI depends on simply making models bigger, then hitting these limits is a serious problem. I believe we're now at the point where architectural innovation, not brute force scaling, is required to move forward. One of the defining features of human intelligence is that we learn continuously. Well, most of us do. Every conversation, every mistake, every new experience subtly reshapes how we think. LLMs don't work that way. Once they're trained, they're frozen. They can't update themselves. They can't absorb new information on the fly. And they can't build long-term memories. Every interaction starts as a blank slate. If an LLM gives a wrong answer today, it will give the same wrong answer tomorrow unless engineers retrain it. A process that takes weeks, millions of dollars, and enormous amount of data, not to mention electricity. There's no accumulation of experience, no growth, no adaptation. And that's a fundamental barrier. General intelligence requires a mind that evolves with the world, not one that's locked in time. Without the ability to learn continuously, LLMs remain static tools, not dynamic intelligences. Intelligence doesn't develop in a vacuum. It grows out of interaction, touching, moving, experimenting, and experiencing the world firsthand. Humans and animals learn by doings. But LLMs don't do anything. They have no senses, no body, no environment to explore. They don't see objects fall. They don't hear sounds. They don't feel resistance or motion. Their entire universe is text and text alone. Because of that, they can't build the kind of grounded physical intuition that real intelligence depends on. They can describe how to ride a bike, but they'll never know what balance feels like. They can explain gravity, but they'll never watch something drop. Without embodiment, there's no feedback loop, no trial, no error, no real-world learning. And I argue that without those ingredients, you can't reach general intelligence, only a sophisticated imitation of it. LLMs may look intelligent, but their entire world is built from one source: human-written text. Everything you know, every pattern they recognize, every answer they generate comes from data created by people, and that creates a ceiling. LLMs can only remix what already exists. They can't run experiments, they can't observe the world, and they can't discover new facts on their own. As the internet becomes saturated with AI-generated content, this problem gets even worse. Models start learning from their own reflections, a feedback loop that degrades accuracy and originality. Without access to fresh, grounded information, they become increasingly detached from reality. For AGI, this is a critical limitation. A truly intelligent system must be able to learn independently, explore new domains, and generate knowledge that isn't already written down. LLMs can't do that. They're confined to the boundaries of human text, and that boundary is far too small for general intelligence. For all their impressive capabilities, LLMs are surprisingly fragile. They can produce brilliant answers under ideal conditions, yet fall apart when the input becomes even slightly unusual. A small change in phrasing, an ambiguous instruction, or a cleverly crafted adversarial prompt can send them completely off course. They don't truly understand context. They only approximate it. And because of that, they can't reliably handle edge cases, contradictions, or multi-step reasoning without stumbling. This brittleness shows up everywhere. Inconsistent logic, sudden shifts in tone, or answers that collapse under scrutiny. It's not a minor flaw. It's a sign that the system lacks the deep, stable reasoning processes that real intelligence depends on. AI can't be something that breaks when the prompt is imperfect. It needs robustness, adaptability, and resilience. LLMs as they exist today simply don't have those qualities. The transformer architecture behind today's LLMs is extraordinary, but it was never designed to be a blueprint for general intelligence. It's a pattern-matching engine built to predict the next token in a sequence of text. That's its core function. And while scaling has made these models surprisingly capable, they still lack the deeper cognitive machinery that real intelligence depends on. They don't have symbolic reasoning. They don't build causal models. They don't form abstractions that persist over time. There's no modularity, no long-term memory, no internal workspace where ideas can be manipulated or tested. Everything is compressed into a single forward pass of probabilities. What is the next word? And that's where it ends. I argue that this architecture simply can't stretch far enough to support true reasoning or autonomous thought. It's powerful, yes, but it's the wrong tool for the job. And no amount of scaling can turn a next token predictor into a mind. As LLMs grow, so does the cost of running them, not just financially, but physically. Today's frontier models already require enormous data centers, specialized chips, and staggering amounts of electricity. Training a single state-of-the-art model can consume as much energy as a mid-sized town uses in a year. And that's before we even talk about inference, the day-to-day operation of serving millions of users. If the path to AGI is simply make it bigger, then we're heading towards a wall. Our power grid can't scale indefinitely, unlike China's can. Chip manufacturing can't scale indefinitely. Even the supply of high-quality data is finite. These aren't theoretical limits. They're hard physical constraints. For me, this is the clearest sign that LLMs cannot be the foundations of AGI. The architecture demands exponential resources while the real world offers only linear growth. At some point, the system becomes totally unsustainable. Large language models are remarkable achievements. Tools that can analyze, generate, and transform information at a scale no human could match. But as we've seen, their strengths don't necessarily point towards general intelligence. They lack grounding in the real world. They have no goals, no agency, no memory of experience. Their architecture is brittle. Their knowledge is limited to human text, and their growth is constrained by energy, data, and physics. None of this diminishes their value. LLMs will continue to reshape industries, accelerate creativity, and expand what's possible with software. But recognizing their limits is essential if we want to build systems that go beyond imitation. Systems capable of reasoning, understanding, and learning the way truly intelligent beings do. AGI may still be ahead of us, but it will almost certainly require new ideas, new architectures, and a new approach to what intelligence really means.